Okay, so let's talk about something we all use every single day, probably without even thinking about it. Just, look around you. Your laptop, your phone charger, the fridge, the microwave. They're all humming along with power that's flowing through the walls. But what is really going on in there? Yep, we all know this guy, the standard US wall outlet. We plug something in, it just works. And we've all been told it's giving us 120 volts. And we just kind of nod and accept it. Sounds simple enough, right? Well, here's the thing. It's not quite that simple. That 120 volts is actually hiding a much more interesting and way more powerful story. It's a number that's true, but at the same time, it's a little misleading. So let's pull back the curtain and see what's really going on. To get to the bottom of this, we have to visualize what's happening inside those copper wires. It's not some steady, boring stream of power. No, it's something much more dynamic, a kind of hidden wave. This is what it actually looks like. What you're seeing is a sine wave. The voltage isn't just sitting at one level, it's constantly, smoothly swinging up and down, changing its direction. That's why we call it alternating current, or AC. And here in the US, this little dance happens 60 times every single second. So if the voltage is always changing, where in the world does that 120 number even come from? Let's break down the numbers on this wave, because this is where it gets really interesting. At its highest point, the electrical push in your outlet actually hits a peak of about positive 170 volts. Yeah, that's a lot higher than 120, and that momentary peak is what really demands our respect. And because it's an alternating current, it doesn't just stay up there. It swings all the way down to a negative peak of minus 170 volts. It's just constantly oscillating between these two extremes. So here's the kicker. The total swing in voltage from the absolute bottom to the absolute top is a massive 340 volts. That's the raw power potential that's pulsing inside every standard outlet in your home 60 times a second. Now, a really good question should be popping into your head. If it goes from plus 170 to minus 170, doesn't the average just cancel out to zero? And if the average is zero, how can it possibly charge your phone or run a toaster? It's a great question, and it gets right to the heart of how AC actually works. This analogy just nails it. Think about it. The saw goes back and forth, back and forth. Its average spot is right in the middle, sure, but it is absolutely cutting through that log. It's the back and forth motion that does real work. AC power is the exact same idea. That constant push and pull delivers real, usable energy. So if we can't use the peak, and the average is zero, how do we measure this effective work-doing power? We need a special kind of average. And that is the master key to this whole puzzle. It's called RMS. RMS stands for root mean square, but don't let the fancy name scare you. All it really is a way to talk about the effective power of an AC voltage. So 120 volts of AC provides the same amount of power, the same ability to make toast, as 120 volts of steady, direct current from a battery. It's the work equivalent value. And the math to get from one to the other is actually pretty simple. For a sine wave like our power, the peak voltage is just the RMS voltage multiplied by the square root of 2, which is about 1.414. So you take 120 volts RMS, multiply by 1.414, and what do you get? About 170 volts peak. The math lines up perfectly. So let's just put it all side by side. When we say 120V for US outlet, we're talking about the RMS, the effective power. But the maximum push, that peak voltage, is really hitting 170 volts. Both numbers are correct. They're just describing different but equally important parts of the same powerful wave. And for anyone who loves the details, the name root mean square isn't just some random term an engineer made up. It literally describes the math. You take all the voltage values, you square them, then you find the mean, or the average of those squares, and finally, you take the square root. That's how you get a single, precise, effective value from that wild, changing wave. Okay, so that's the math. Pretty cool, right? But more importantly, understanding these real numbers is the first step toward being a lot safer. Let's bring this all together and see how this knowledge actually helps you in the real world. Seriously, go grab any phone charger or laptop adapter you have lying around and look at the tiny print on it. You'll see a bunch of numbers that might have looked like gibberish before, but now we can decode them. You'll often see something that says input 100 to 240 V. Now you know what that means. That range is talking about the RMS voltage. It's telling you that this device is designed to work safely with the 120V RMS system we have here in the States and the 230 or 240V RMS systems they use in many other countries. And it's not just about international travel. Even in your own home, it's not all 120 volts. See that big, beefy outlet for your electric dryer? That's probably a 240V RMS circuit. And if you do the math, a 240V RMS system has peaks that get all the way up to about 340 volts. That is a serious amount of electrical force.
And this brings us to the most important point of all. Understanding that 120 volts really means peaks of 170 volts should give you a very healthy respect for electricity. This knowledge is for you to be aware and make safe choices, not for you to go trying to fix things yourself. Please leave any risky repairs to the professionals.
So let's just remember the basics. Water and electricity, a terrible combo. A frayed cord is a cord that's retired. Throw it out. If a plug or an outlet ever feels hot to the touch, that's a huge red flag. Unplug it. And remember, while voltage is the push, it's the current that actually flows through your body that causes the real harm. Always, when in doubt, call a pro.
So now you've cracked the code. The familiar 120V outlet is really a powerful wave swinging a total of 340 volts, 60 times a second. Knowing that the real peak is 170 volts doesn't just make you smarter about electricity, it helps you be safer. And it kind of makes you wonder, what other simple numbers that we see every day are hiding a much more fascinating story?